Hey there, everyone. My name is Rubitel, Bluehand Coding on TikTok, and welcome to the third lesson here on teach.tv. Again, I'm going to give it a minute or two so that everyone who wants to join can get in here. But how is everyone doing? I'm assuming that, with this being our third lesson, that most of the people here have been here for the first two lessons. Hey, Maria, how are you doing? I'm doing good. As always, I'm excited to be here. We're going to have a good stream. We're going to go into some good stuff today. So I think I'm going to go ahead and just get started then. So this lesson will be an hour and 30 minutes long, just like yesterday's. So let's start with a review of what we talked about in yesterday's lesson. So yesterday we went over commenting out your code. We talked about those mathematical operators, your comparison operators, your Boolean operators. We had our input function. We talked about those if statements and those else statements. And we built a couple of mini projects just like this one right here. So let's go through and review all of that. So the first thing we talked about were comments. And as I said, comments are things that are not read by Python, but they allow people, when they look at your code, to understand exactly what's going on. So it's important for documentation. And as I said yesterday, readability is the #1 priority when it comes to programming. It's the #1 way to ensure that when you go back, 1 month later, 2 months later, to look at your code, you know exactly what it's doing. So how do we write a comment? Well, a comment just starts with this little hashtag, the #, if you will, and you can just type exactly what you need to. So let's say, we're just going to take user input, right? What is your age, right? I'm going to print user input out, print that age out, right? Of course, this is pretty simple, so it really doesn't need to have comments. But let's say you're, talking to someone who doesn't know how to code in Python, then it might be helpful to ask or to put a comment that says, puts prompt in console to ask for age, prints out age to console. Of course, these are kind of obvious. It's a print statement. So it's not the best example, but you get the point. It's there, so you know exactly what it does in plain English. And of course, when you run this, you'll see that Python doesn't do anything. You don't get any errors for that, but you don't see it in the output of your code either. The next thing we talked about, mathematical operators. What are those? Well, that's your addition, that's your subtraction, that's your division, your multiplication, your exponent, your floor division, and then your modulus, right? So we talked about all 7 of these. So I'm not going to go over addition, subtraction, division, multiplication, exponentials, because I'm sure you guys are all pretty aware of those 5. The last 2 that I talked about and I had to go in a little bit more in depth with yesterday were these 2. So this is your floor division, right? So floor division, that's this thing. And then your modulus operator is this little percent sign. And we're just going to do the same sort of example with both of them. So I will print 75. Let me check the example I wanted to use. Yeah, 75 and 6. So I'll do 75 floor divided by 6. And then we'll print out 75 modulus by 6. If I run this, which it looks like my REPL just disconnected there, But if I run that, I get 12 and I get 3. And I've actually pulled up a little diagram to help explain that. Recall that the floor division gave us 12 and the modulus operator gave us 3. So I talked a little bit about this long division example, but I didn't have any way to sort of draw it out for you guys. But if you've seen this before, this is what long division looks like. You have your divisor and your dividend. So you can see that 6 goes into the number 75 12 whole times. So that's that 12 right here, the amount of whole times that the number 6 can fit within the 75. But then you're left with that remainder, the amount of times that that 6 can't fit. And so that's what your modulus operator tells you. It's that remainder of your long division. So hopefully that clears it up, because I know there was a little bit of, it was a little weird how I explained it yesterday. Alongside that, we also talked about our input function, which I did a little example with earlier. What is our input function? Our input function is the way that we can make our code significantly more dynamic. We can give it input from the console, and then the code can run with that and do what it will. So I think an example we had yesterday was we asked for the user's age. We said, what is your age? And if we print that out, we see that it prints out whatever age I type in. We then use it to do a little bit of like addition, some math, showing how we can build in those int, float, and str functions. So remember, if I try to do age plus 1, I should get an error, because the input function returns things as a string. And as our error tells us, you cannot concatenate a string and an int. You can't add two different data types together like that. So the way we solve this is by either wrapping this in that int function, right, which will give us our desired output, or we can wrap the age variable whenever we reference it. We can wrap that in that int function. So we get the same result no matter what we do. So we talked a little bit about that. Then we started discussing our comparison and Boolean operators. Okay. So if I open up our diagram right here, we have these two diagrams. But what was a Boolean? Well, a Boolean is a data type. Remember how I talked about how in programming we have this sort of binary thing, right? Something can either be true or it's false. It's a yes or a no, black or white. So it usually falls into two different categories. And the ability to have something be true or something be false gives way to programming logic, which is that logic which we explored in this little diagram right here. Okay, so what were our comparison operators? Well, we had our greater than, we had our less than, we had our greater than or equal to, we had our less than or equal to, and then not equal to, right? So how does this play into the idea of binary? How does it play into the idea of something being true or false? Well, let's create an expression right here, right? We're going to say 5 is greater than 4. We're taking two things, right? Taking a 5 and we're taking a 4, and we're comparing them. And we're using this comparison operator right here, the greater than sign. So if you read this out in English, right, it basically says 5 is greater than 4. Okay? Well, 5 is greater than 4, so that comes out to being true. True, right? So that's how you use those comparison operators to sort of, create that idea of true and false. Then we had our Boolean operators, which we touched upon a little bit, and we're going to touch upon them a little bit more in this lesson here. We had our and, our or, and our not. I'm going to come over here to this truth table diagram that I talked about yesterday. And we're going to go over this. We're just going to go over this first sort of row right here. But if you remember, let's say we have two things, right? And we're going to compare them with a Boolean operator. The first thing I have is false, right? X is false. Y is false. They're both false, okay? What does not X do? Well, we know X is false, so this is basically just saying not false. Well, if something's not false, then it's true. So with that in mind, we can say that the not Boolean operator basically just flips the Boolean value of what you have. Okay? Our and, x and y. So x and y are both false. So it's saying false and false. Well, if both things are false, then the whole thing comes out to being false. So if you remember, in order for something to be true with an and, both of them have to be true. So in this last row right here, we have x being true, y being true, and therefore x and y, that comes out to being true. With our or, only one of them has to be true. So both are false here, so the whole thing is false. One of them, at least one of them, is true for these two rows. So therefore, this whole thing comes out to being true. And I realized after our lesson yesterday that that sort of just wasn't, that good of an example. So I'm going to show you today, to start off at least, how we could sort of visualize those Boolean operators and visualize the Boolean data type within our actual code. So let's go ahead and start off with that. So basically, if you remember our data types, right? Let's remember the key data types we have. We have our string, right? How do we know if something's a string? It has those double or those single quotes, right? That identifies a string. How do we know what's an integer? Well, it's usually just a whole number like that. Then we have our floating point. So you have your pi, so 3.1415926, yada, yada, yada. How do we know this is a float? Well, we have that decimal point right there, which tells us that this is, a floating point value. It's being very specific. There's one more data type, and that's that Boolean data type. And of course, with the Boolean being only true or false, that means a Boolean is either just true or false. And that's literally how you write a Boolean in Python. You see how it's a little bit of a light blue. So it's getting that syntax highlighting from the REPL site. So if you print true, just printing a Boolean right there. It's the same thing as printing a string or printing a number. If we run this, we don't get any errors or anything like that. But if you remember correctly, you can use Python to sort of evaluate those expressions, like, 5 is greater than 4. You can evaluate these within your print statements. So we're going to use this to sort of explore our truth table diagram. So let's take a look at that and, first of all. Well, we know that an and will only give us a true, right? We only get that true output if both of our conditions are true. So if true and true, right? If true and true, then it's going to be true. So if I run that, we get true right here. Okay, sorry about that. So let's try this with another example, with another true, but we'll make one of our conditions false. But do true and false, what do you guys think we're going to get? Well, if we go over to our truth table, we see if one of them's true, the other one's false, then the whole thing comes out to being false. Let's check that out. Oh, there we go. That's false. And if we make both of them false, false, and false, the whole thing comes out to being false. So take this as an example to show how with the and Boolean operator, both of our conditions need to come out to being true. Now let's take a look at our or. So I'm just going to get rid of these. Actually, I'm just going to swap these out. So we have an example where both are true, where one is true, and then none are true. So I'm actually going to open this up to you guys. What do you guys think will happen when I run this out? What will be printed to the console for all three of the ones we have right here? Yeah, true, true, false. And if I run that, true, true, false. So good job. Deepak, Maria. So yeah, because we know that at least one of these conditions, we have at least one true. And if we go to our truth table, true, 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 false, true, but false, false, that is false. So good job, guys. And then we have our not operator. And if you remember, our not is just going to flip what we have. So this should be pretty simple. If something's not false, then it's true. If something's not true, then it's false. So there you go. And there's those Boolean operators. And this is how you write those Boolean data types out in Python. So that's how those Boolean data types work. So let's build on what we did yesterday, because while we did get to work with those comparison and Boolean operators and those if statements, let's really make sure that we're solidifying what we understand. So I think yesterday we had a little project, and I'm going to go over to this this lesson 3 REPL instead of staying in the lesson 2 REPL. But let's rebuild that project we had yesterday, where it's sort of like we categorize the voter. We categorize what voting category a person might fall into based off of their age. So I think our prompt was like, we're just going to say categorize a voter into a specific category based on their age. Okay? We're going to say people who are 18 to 24 are young. That's our young category. Okay? And we're just going to add one more case. We're going to say 65 to 100. That's our senior category. We'll just have those two categories. I know I'm skipping out in a bunch of years, but let's just leave it there. So yeah, how do we start with this? Well, first we want to take our user's input, right? We're going to say age is equal to the input. Please enter your age. And let's just make sure that this works, right? I run this. Please enter your age. I'm 17. There we go. Our age gets printed out, so we know that part of our code is working just fine. So now we need to find a way to categorize our voters based off of our age, right? How do we know what category they fall into? And if they don't fall into a category, what do we default into, right? So yesterday, we didn't really build into this whole senior thing. But we did talk about that young category, right? And how did we do that? Well, one of the things we first had to do was, in order to compare the numbers, right? In order to say this, our age value is greater than 18 and less than 24, we had to turn this thing into an integer. Because if you guys remember correctly, our input function yields things as a string. And you can't say something like 13 is greater than 12, because it's like comparing a sentence to a number. Doesn't really work out like that. Okay. So how do we write those if statements? Well, we had that our if keyword, right? If. And then we had our little expression. So I'm going to say our age is greater than or equal to 18. And our age is less than or equal to 24. And then we had that colon. And once we pressed enter, it tabbed us in. And from there, we can just print, you are a young voter. So let's go over what I did here. I created an if statement. So just like that control flow thing from our last class, right? Where you check if it is raining, then check for an umbrella, things like that. We're doing the same thing here. So I have my if keyword, and then I have the full expression I want to evaluate. I want to evaluate first, is my age greater than or equal to 18? Then I want to evaluate, is my age less than or equal to 24? And these two things will either yield a true or a false. And then you use that AND operator to come to a single answer. So let's go. If I type in 17, right, nothing will happen, right? But if I type in 18, as you are a young voter. So why is it that when we typed in 17, it didn't work, but when we typed in 18, it did work? Let's go through our code. So we'll start with the 17. I typed in 17, it gets turned into an integer. Cool. Now we're going to come here, and we're going to say, okay, is my age, so is 17 is 17 greater than or equal to 18? And is 17 less than or equal to 24? So I'm just plugging in that 17 for that age variable right here. Well, this 17 is greater than or equal to 18. That's not true. So that's false, right? And then we have 17 is less than or equal to, should be 24. Well, that's true. 17 is less than or equal to 24. True. Well, what do we know from our truth tables? False and true. That comes out to being false. So since this is false, it won't run that code. But if we do this with 18, let me just tab back, or sorry, Control Z back, replace all the 17s with 18s. If is 18 greater than or equal to 18? Well, it is 18, so that means it's true, right? And 18 is less than or equal to 24. That's true. So that's true. Well, true and true, that ends up evaluating to true. And since that comes out to being true, that whole sort of expression, that's why we get that whole young voter thing printed out. Okay, so that's our if statement. If you remember correctly, yesterday, I also talked about our else statements. What does the code default upon if our condition isn't met? So like when I typed in 17, nothing got printed out. But what if I wanted something to be printed out? What if I wanted that default? So I'm going to type in else, and notice how this is not tabbed in. It's on the same level as that if. And as I said yesterday, it's all about building that sort of hierarchy. So we have our else, and then we have our colon. Press enter, we get that tabbed in space. I'm going to say print. You do not fall within a voting category. Okay. So this else, right? If this if doesn't work out, then we're going to default onto this else. So let's try this with our 17 one more time. So yeah, you do not fall within a voting category. We already know with 17 that this whole thing will come out to being false, right? So since that's false, this whole section of code won't run. So we're going to fall onto this else statement. This else statement is saying, print, you do not fall within a voting category. So that's how we get that output right there. Perfect. Now let's build in with this senior thing. So now we're going to add in something to check for that 65 to 100. You might be thinking, okay, so we need to have another expression that just looks something just like this, right? We'll replace the 18 with the 65, the 24 with 100, right? But how do we add like another if statement, right? Do we just, tab back in, type if, and then add another expression? No. We use something called an elif. We're going to use an elif. An elif basically reads else if. So let's take this this expression with our colon and everything. We're going to print you are a senior voter. We're going to change these numbers. We're going to make it 65 and 100. I just did a lot, so let me go over what exactly I did. I wanted to add in something to check for our senior citizens, right? So I added in another if statement. So it's an else if. So if this is true, do that. Else, if this is true, do this. Else, do that. That's basically what it reads out with plain English. So we have our elif, then we have our expression, and then we have our colon. And if this expression comes out to being true, then we print you are a senior voter. So let's try this, and we'll try it with the age of 70. And it says you are a senior voter. So let's see what happens when I type in 70 and how we go through all of our code. So I'm going to type in 70. That's my age. It's an integer. Cool. Let's start with this first if statement here. Our Python code is first going to check, is 70 greater than or equal to 18? And is 70 less than or equal to 24? 70 is greater than or equal to 18, right? So that's true. but 70 is not less than or equal to 24. So it's false. And as you guys know, true and false, that comes out to being false. So this whole thing evaluates to false when we give it the age of 70. So therefore, this section of code won't run. So then Python is then going to move on, and it's going to check with this one. And it's going to say, hey, is 70 greater than or equal to 65? And is 70 less than or equal to 100? Well, is 70 greater than or equal to 65? That's true. And is 70 less than or equal to 100? That's also true. We have a true and a true, and that gives way to a true. So then we know that this whole expression is true. And it's going to run this block of code. You might be asking, well, okay, it's going to run this block of code, but why doesn't it fall back onto this? Because one of our expressions came out to being true, it only runs that section of code. Remember, this is a default if nothing else works. So that's how that works. And I'm actually going to go and just like read this out in English so you can see how it like sort of fits in. Take your age. Am I between the ages of 18 and 24? If I am between the ages of 18 and 24, then print that I am a young voter. If that's not the case, check to see if I'm between the ages of 65 and 100. If that is true, then print out that I'm a senior voter. If none of these work, then tell me that I have not fallen within a voting category. So that's how we have our if, our elif, else if, and our else statements. So any questions with that? Because that was our whole review of all of our second lesson. And I'm sure it must have gotten a little confusing with how I might have explained. So if you have any questions, let me know. But if that's not the case, then we can go ahead and actually move on with lesson 3. All clear from Maria. Awesome. Deepak, you good, man? Because if he's good, then we're going to go ahead and move on. Okay, awesome. Cool. So again, just to reiterate what we talked about our comments, we talked about our mathematical operators, comparison operators, Boolean operators, our little Boolean logic, our if, elif, else. So we talked about a lot and we kind of went over it fast. So with that in mind, I ask you guys that after class or whenever you get some free time, just sort of come up with some project ideas and just try them out. Just keep building and just sort of, cut in with that. You might want to check out a website called practicepython.org. This has some these exercise ideas that you guys can work on. A lot of these concepts we haven't touched upon yet. We're actually going to touch upon them today in this lesson. But for example, this rock, paper, scissors game, you can use like some user input. You can compare if this person put rock, this person put scissors, and use that to sort of build something like so. So cool. Actually, let me ask, do you guys want me to build a rock, paper, scissors game to sort of as an example for this? Or would you guys like me to move on with today's lesson? Because if we need a little bit more, I don't mind. It's pretty simple and it's pretty fun. So we can do that if you guys want. I'll leave it up to you. Okay, yeah, let's just do it then. Let's make a simple rock, paper, scissors game. Because then you could like share it with friends and yeah, we'll make it a 2-player thing. Because today's lessons, it's not that, we can be fun with this. Okay, so rock, paper, scissors, right? So let's talk about the things we're going to go over, the techniques we're going to use with this. We're definitely going to be using our input function, right? We'll make this a 2-player game. We're going to be using our Boolean operators, right? We're going to be using, I think, just our Boolean or our comparison operators as well. Comparison operators. I don't even know if I'm spelling this right. Operators, yeah. These are the 3 main things that we're going to touch upon with rock, paper, scissors. So let's just try to remember, what are the rules of rock, paper, scissors? Well, you pick three things, right? Three little elements. And we know that rock beats scissors. We know that paper beats rock. And we know that scissors beats paper. These are the three governing rules of the game, right? And I think I got them all. Rock beats scissors, paper beats rock. Yeah, I think that's right. Okay. So you're playing a game of rock, paper, scissors. Let's sort of visualize what we're going to do, what we're going to have our code do. So we're thinking, okay, rock, paper, scissors. Well, the first thing you guys do is you pick your element, right? So we need to have a sort of player one choice and a player two choice. So player one choice and player two choice. Okay? You're saying, okay, so you're going to do rock, paper, scissors, shoot. So that's the moment where you pick something. So when they pick, that means you have to take their input, right? What element does player one choose? Okay. And then with that, we can do what element does player two choose? There we go. So rock, paper, scissors, shoot. So there we go. That's our first sort of component. And let's just check to make sure that that's working out. I'm going to make this a little bit smaller. If that's still okay to read, I'm just tired of how it like overflows onto the next line. We're going to print out player one choice. We're going to print player two choice. Okay. What element does player one choose? Well, I'll just say he will pick rock. She'll choose scissors. Rock, scissors. Cool. First part of our code works perfectly. Okay, so let's go back to our visualization. Rock, paper, scissors, shoot. So we've picked our elements, and then in our minds, we're going to compare what player one and player two put. So if you get a rock and a scissors, well, you know that rock beats scissors. So the first thing actually would be to check if they tie. What happens if player one puts a rock and player two puts a rock? Well, nobody wins that. That's a tie. That's the first thing we should check for. If player one choice, we're going to touch on our comparison operators. I'll put it right up here so we don't forget. Greater than, less than, greater than, equal to, less than, equal to, and not equal to. Well, what operator can we use if we want to see if two things are equal to each other? Our equal to operator. So if player one choice is equal to our player two choice, right? That's our expression. I'm going to put it in, again, this whole parentheses thing that I put in it, it's not really mandatory. Again, it's one of those convention things. And as I say, readability, that's our number one priority. So this just makes it easier for us and other people to understand. So this is saying if player one picks the same thing that player two picks, what do we want it to do? Well, we're going to tell it it is a tie, right? Let's try that out. Let's test it with that special scenario. Actually, I'm going to run this again because it seems like it has like that weird overflow. So what element does player one choose? Well, player one is just going to choose rock. Test out to make sure that our code works. Let's also say that player two chose rock. Okay, and that works out just fine because both of them pick the exact same thing. So it's a tie. Cool. So we have our tie built into place. So now let's check for these scenarios. So the first thing we need to do is we're going to have that else if. So if it's not a tie, then it's going to be something else. So elif. Okay. So we can go a lot of ways with this. So first, let's check. Let's check if player one, right, chooses rock, but then player two chose paper or scissors, we get different things. So the first thing we want to see is if player one's choice is rock, then we need to check to see what player two's choice is. So now we're actually going to talk about a nested if statement. So now we're going to talk about nested if statement. So a nested if statement is just like what it is. It's just an if statement underneath an if statement. So I'll type it out and then I'll be sure to go over it. So I'll try to like read it out in English. So as I'm going along, you guys can sort of see what's going on. So if it's not a tie, then check to see if he picked rock. Okay, so let's say he picked rock. If player 2 is then picking paper, well, we know that paper beats rock. So you print that player 2 wins. Else, player 1 wins. So this might be a little confusing. So let's go over it. We already figured out our whole tie thing, right? So now we're saying, okay, player 1 has chosen a rock. There's no way he could have chosen, like player 2 could have chosen a rock because we already called for that. So that means player 2 either chose paper or player 2 chose scissors. There's two things that could happen, right? If player 2 chose paper, we know that paper beats rock. So that means player 2 wins. If they didn't choose paper, that meant that they chose scissors. So this is basically saying L if player 2 choice is equal to scissors, right? I left it as an else statement because there's really nothing else to check. But I'm actually going to leave it like that so it just makes more sense. But if our player 2 chose scissors, then our player 1 wins because they chose rock. And I'm actually going to stop there. I just want to check in with you guys. Does this nested if sort of make sense? And I'm starting off with a new if. I'm not putting an elif right here because it's nested underneath one. It's like it's checking for a brand new set of expressions. So I want to hear from you guys. Is this making sense so far? This whole block of code that I've highlighted right here. Okay. Okay. Again, stop me if you need to. Just throw a message in the chat. Okay. So we've checked for a tie. We've checked if... So you only use elif for the final statement only. Well, this elif, again, this could have been an else. Yeah. We could have had this as well. These do the exact same thing, having this elif and this else, because this is only like, this is a special situation. Because if it's not paper, then it automatically has to be scissors. So there's no need to make that very explicit because it's the only other thing that could be there. So therefore, I just put an else. You don't have to specify that condition. I'm only leaving this elif in here for the sake of, so you guys can understand what our code is actually doing. So that it's obvious that it's going to check for paper and then it's going to check for scissors. If that makes sense. Okay, so we check for a tie. We check to see if our player 1 chose a rock. So now let's just copy this block of code, right? And we're just going to check to see, and I'm just going to have some white space so we can sort of cut it up a little bit. Now, instead of checking for if they chose a rock, we're going to see if they chose paper. Well, if they chose paper, if player 1 chooses paper, right? Player 2 chooses either rock or scissors. So if player 2 chooses rock, if player 1 chooses paper, player 2 chooses rock, well, we know paper beats rock, so that means player 1 will win. Okay? And we have player 1 chooses paper, player 2 chooses scissors. You know, scissors beats paper. It means player 2 wins. So that's how that sort of logic builds in. And then we have our last thing to check for. So we have rock, paper, and then we have scissors. Okay, so player 1 chooses scissors. Player 2 chooses rock. Rock beats scissors. That means player 2 wins. We're going to make this paper. So if player 1 chooses scissors, player 2 chooses paper, we know that player 1 would win that. That's sort of a whole game of rock, paper, scissors. It's just one round because I haven't taught you guys how to create loops. And that's actually the next thing we're going to talk about. But this is sort of like a whole game of rock, paper, scissors in code. So let's talk about it. Let's talk about how this can sort of connect back to real life. Let's visualize it like I did at the beginning. You're going rock, paper, scissors, shoot. That's the moment where both players pick something, right? Let's say both of our players, they put down scissors. Well, they both have the same thing, so it's a tie. There's no need to go on and check for anything else if it's a tie. Okay, let's say that player 1, this hand right here is player 1, chooses a rock. Well, there's no need to check for player 2 having a rock because we already checked for that tie earlier. So that means we need to check for a paper and a scissors. So if player 1 has a rock, player 2 has paper, paper beats rock, hence player 2 wins. Player 1 has a rock. If player 2 has scissors, then player 1 wins because rock beats scissors. And this is the same sort of logic that follows with these other two. So now let's try this out. So first little game that we've made. What element does player 1 choose? I'm going to pick rock. What element does player 2 choose? Or say player 2 chooses paper. So we know that what this should do is it should have player 2 be the winner because paper beats rock. See, player 2 wins. And of course, this is not really that good of a game because the people can see what they're putting at like this at different times. So I choose rock, we have our tie. Let's do paper and scissors. You know, scissors beats paper, so player 2 should win. So that's a little game of rock, paper, scissors. And we've used our input. We've used our comparison operators. We didn't actually use our Boolean operators, but we did use these if statements. We did nested if statements as well. So that is awesome. Any questions with that? You guys should like save this. And if you do want to save this and share it with your friends, you can just create another file right here. Actually, let's do that. Let's create another file, rock, paper, scissors.py. .py stands for Python, python. So that's like the sort of ending. We're just going to go ahead and cut that and paste that there. Just so you can save it, you know, be proud of yourself. Because that's awesome. You guys have created like a proper game. And with things like this, I do recommend sort of like trying to visualize it, seeing how it happens in real life, and then taking all those little steps and then just coding them out, just like we did, right? We identified the first thing is that you have to pick, right? You pick your elements and then you compare. Cool. Is everyone okay with our little game of rock, paper, scissors? Are we okay with those comparison operators, those Boolean operators? Because if so, we can start with, now we can start with lesson 3. Okay, perfect. Deepak's giving me the yes. So let's start with lesson 3. Maria's okay? Awesome. Lesson 3, I'll give you a quick overview of what we're going to talk about. We're going to be talking about loops. We're going to have our for loops, our while loops, and honestly, that may take up all of the time we have left because, of course, I do want to review with you guys. So I think for now, those are the two things we're going to touch upon, our for loops and our while loops. And if we do have time, we're going to review, and we're also going to talk about functions, creating our own functions. So loops. What is a loop? Well, a loop, you just do the same thing over and over and over and over again, right? So if I go over to this control flow diagram, you might remember that yesterday I kind of skipped out on this whole little section of the diagram. So you see it's checking, is it raining? And if it is, it's going to wait. And then it's going to check again, and then it's going to wait. So this in itself is a loop, right? You're just going back, checking, If nothing's happening, then you're just going to keep checking. You're going to keep checking. So that's what a loop is. It allows you to do repetitive tasks over and over again. So let's talk about loops. It just allows you to repeat code over and over again. So there's two types of loops. So two types of loops. We have our for loops, and we have our, oh, I didn't mean to type that out. We have our for loops and while loops. These are two types of loops, okay? So let's start with a while loop, okay? So we're gonna have, let's just make a simple while loop, okay? Basically with a while loop, you type in while, okay? And then just like with your if statements, you can have an expression. And as long as that expression is true, your loop will keep doing its thing. So we're gonna make a variable right here. Actually, we're gonna start with a variable. We're gonna call it counter, okay? We're gonna make it 0. And while our counter is less than 10, right? I had my expression, my colon, and then I tabbed in. So it's pretty much the same for all of these things. So while counter is less than 10, I'm going to print counter, sorry, the variable counter is less than 10. Okay? If I run this, I get what's called an infinite loop. You might see at the bottom of your screen. You may not be able to see it since I have my display capture over the thing, but it'll just keep going forever and ever. So if I'm just going to press stop right here, so this stops running. Okay, perfect. So what did we just create? Well, we created what's called an infinite loop. This is bad, by the way. How did this happen? Well, basically, whenever this expression keeps coming out to being true, right, then the loop will just keep running. Counter is 0. So it's basically saying, well, 0 is less than 10. Well, 0 will always be less than 10. So this will always be true. And therefore, our loop will continuously run over and over and over and over. So let's see how we can make our loop only run for a certain amount of time. Basically, we're going to take our counter variable. We're going to say counter is equal to counter plus 1. I'll be a little bit confused with what I'm doing here, but I'm just going to run it, and let's see what happens. Okay, so it stopped. It's not going on infinitely. So what did I do here? Well, I'm saying that counter is equal to 0, right? I'm starting off my code like that. The first time I enter my loop, I'm saying, hey, counter is now equal to the counter variable plus 1. So I'm just adding 1 to the counter variable. And another way to write this, which I recommend instead of writing this, is plus equals 1. So you're just adding 1 to the counter variable. You're incrementing it by a value of 1. And if I run this, we get the same exact output. So I'm actually going to use our little f string, and we're going to print out what the counter variable is as we go through the loop over and over. Right? A REPL lost connection again. Okay. Huh. So it's saying the variable counter is 0. Let's go through this step by step. I start my code. Okay. Counter is equal to 0. At first, it's going to check right now, is counter still less than 10? Yes. So then it's going to run through this part of the code. That's why when we first run it, we see it's 0 right here. And then it's going to say, okay, now I'm going to add 1 to our counter. And it's going to come back up here and check, okay, is our counter still less than 10? Well, we've only added 1 to it, so our counter value is just 1. Okay, it's still less than 10, so now we're going to run this part of the code again. So now our counter variable has a value of 1, and then it's going to add another to it. And then it's going to go back and check, is our counter variable, which is now 2, still less than 10? Yes. And it's going to do that until it gets to, let's say, 8. Okay? It's printed out that the variable counter is now 8. It's going to add 1 to it. Now it's 9. So we're going to come back up here. Is our variable 9 still less than 10? Yes. It's going to print out that 9 right here. But then it's going to add 1 to it. So now our counter variable will be 10. So when it comes back to check it right here, is 10 less than 10? No. So then it's going to break out of this loop. This loop will exit. So we see that if I print right in here, our loop has ended. If I run this again, we can see it only runs after we break this condition. After this expression evaluates to being false, then it'll exit this whole block of code, and we'll get to this. So that is our sort of while loop. Does that make sense with everyone? Okay, awesome. So that's our while loop. And with while loop, there's a couple of special things that I would like to talk about with you guys. We're going to talk about 2 keywords. So our while is a keyword, our if is a keyword. Those are all keywords. I want to talk about 2 keywords called break and continue. So break makes sense. If something is met, then it's going to break out of our loop. So how can we build that? Well, let's say we want it to exit our loop as soon as our variable turns 5, right? So we're going to say if counter, right? Our counter variable is the thing that's increasing every time. If it suddenly becomes 5, right? Then break out of our loop. So now let's run that, and we'll see how, even though this condition is the same, it's not going to go all the way to 9. It's only going to go to that 5. So what this break is doing is it's going to check, and if this condition, if this this expression comes out to being true and it evaluates to being true, then it's going to break. It breaks out of this loop. So that's your break keyword. And it does it on the 5th time because, again, we're checking. We're saying if our counter, right, this variable right here, after it's been, what's it called? Incremented, sorry, and it becomes 5, then it's going to break out of that loop. Okay? What about that continue keyword? So I'm going to get rid of this break thing. And what if I don't want it to? So yeah, we're back to our normal thing. Oops. Back to our normal thing. And what if I don't want it to print that 4, but I want it to go all the way to 9 still? Well, I can say if our counter is equal to 4, right? And we're gonna continue. We're gonna add 1 and then we're gonna continue. What's that doing? Well, I'm saying, hey man, my counter is finally 4. Add 1 to the thing, but just don't print it out. Continue takes it back up and restarts the whole thing. So if we see that now, that 4 isn't there. We've sort of skipped it. So let's see how that plays out. So if that counter is 4, right? I'm starting and it's 4. It's less than 10, so we're gonna our loop is gonna continue. Our counter is equal to 4. Well, that's true. It's gonna add 1 so that we don't have like a gap, right? It still goes up to 9, but it's gonna continue. And what that continue is gonna do is it's not gonna execute any of this. It's gonna take it back up to the top, and it's gonna bring it at 5. So you probably won't get a lot of use with continue. Break is usually the one that you shouldn't use more often. Continue is sort of just like there. am confused. Yeah, continue is a weird one. I'm actually not going to continue explaining this because I actually want to save it for another lesson where we'll work with it in a project. Because I feel like if I just explain it with this example, then it's not really going to make sense. The only thing that should sort of click right now is the break keyword, because you're just breaking out of the loop, and then you have just how your while loop works in general. So if we're okay with that, I'm not too worried about this continue thing. It's one of those things that'll just come with time. But if we're okay with the break and the while loop, let's build a simple project, okay? Just to make sure that what we know, or what we're doing at least, is sort of clicking in our mind. So let's try to make something that's a little bit more real world, right? Whenever you type in your password into your computer, you turn it on. You see, you can get a couple tries to like type it in. If you don't get it right within like 5 tries, it breaks, right? You don't get any more attempts. So let's try to implement something like that with Python. So let's create like a password validation system that gives the user 5 attempts to get the password correct. Okay? We're going to build that. We're going to use a while loop with that. The first thing we need to do is actually have a password. So we'll just call it password. And of course, in real code, this wouldn't be that obvious. But just for the sake of what we're doing, let's say we'll just make our password blue hand coding. Okay? That's going to be our password. First thing we need to do is we need to take our user's input, right? We need to see what they have to say. So we can say that our user guess or user input is equal to the input. What do you think? Sorry, I'm just going to put enter the password. Enter the password. Right? Let's just make sure that all works. Let's print our user guess out. So let's see if that works. Enter the password, whatever. Cool. That works. So we're getting our input from our user. Now we need to have something to verify it, to make sure that it's correct. Okay? So while, right, because we want to keep checking over and over, while our user's guess is not equal to the password, right? So let's say I put my name. I just put Varun as my guess, right? But the password is blue hand coding. While it's not true, right? While those things are not equal, we need to ask them to enter it one more time. I'm going to take this again. Enter the password. So let's run this, and this might seem a little confusing. So right now, this first prompt, it's right here, right? It's asking us to enter the password. And let's say I enter the correct password, right? Blue hand coding. Our code exits. It stops. Why? Because this does not evaluate to true. Because what we have then is basically blue hand coding, which is my guess, is not equal to blue hand coding, which is the password. That's not true, though. Blue hand coding is equal to blue hand coding. What happens if we enter the wrong password? I'm just going to put LOL. And we get another attempt to enter the password. So that first prompt right here, right? That second prompt, however, comes with our loop because we've made it to that point in the code. So if I keep typing in the wrong password over and over and over and over and over, whatever it is, I can type gibberish, it won't exit the while loop. Why? Because they're not equivalent. And it's going to keep running while they're not equivalent. So if all of a sudden I type in the right password, blue hand coding, exits. Why? Because finally our user guess and our password are the same thing. So this means this would become false. Okay, so we sort of created a validation system. So how do we then create a 5 attempt thing? Well, the first thing we should do is have a counter, just like we did with our previous while loop, to see how many attempts they've made. So we'll just say attempts. is equal to 0, right? And every time you make a guess, we're going to add 1 to our attempt, right? Attempts. If I run this again, everything just works fine. So blue hand coding and it'll exit. So let me print out the number of attempts it takes at the end. You see how I tab in? So I'm outside of this while loop because I'm not within that same sort of region of the tab space. So I run this again. I'm going to just type a bunch of gibberish for a couple times. Then I'm going to type blue hand coding. It took me 3 attempts, right? This first one, this second one, this third one. Okay. So if the number of attempts ever equals 5, right? So they've hit their 5 attempts quota. Then we're going to say print. You have been locked out of the system, right? And then we're going to break so that the while loop doesn't continue. So let's run that again. I'm going to say hello. Gibberish, 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 gibberish. You have been locked out of the system. And actually, we had 6 attempts. The reason why is because I set this at 0, even though this is our first attempt. So it actually should be like this. If I run that again, here we go. We get locked out of the system. Yeah. So, all right, let's have a couple of wrong attempts, right? Let's just say we put a capital B instead of a lowercase b. Blue hand coding. That's wrong. It asks me to put it again. Maybe it's something else. Maybe it's my name. Nope. Okay, let me try the correct blue hand coding. And when I do that, it works. Maria asks, what does the attempts plus equal 1 stand for? So this is basically saying every time I make a guess, I'm basically making another attempt. So it's adding 1 to this attempt counter, if you will. So this attempts thing it's a counter of how many times you've tried to put in the correct password. So this plus minus, it's just like how I talked about attempts is equal to attempts. It's 1. That's just a shorter way of writing that. And actually, I'm going to comment that so you can, that's still there for you to reference. So cool. That's our while loop password validation system that we have built. Is everyone okay with that? We've used our break keyword. We've used our while loop. We used our comparison operators. We used our input functions. So everything is starting to sort of come together a little bit. We're working with strings. We're working with integers. So everything should be, slowly at least, should be tying together a little bit. And again, one of these while loops, these loops in general, they're a pretty abstract concept. It's hard to see these things. So you sort of have to try and visualize it to the best of your abilities and try to get as much practice as you can with it. And I apologize if you guys can hear, like, outside there's a little bit of commotion. But is everyone okay with this little project that we've built with our while loops? Okay. Awesome. Awesome. And of course, if you guys have questions, all of my social links and everything, they're all right here. You can click on these. And from here, you can contact me if you have questions after class or whatever. Cool. So we've done our while loops. Let's get started with our for loops. So for loops, they're a little interesting. With our while loop, remember our syntax is that you have the while keyword, and then you have your expression, and then you have your colon, and then you tab in. Pretty simple. For loops are a little bit more complicated with how you structure them. So now we're going to look at for loops. But the cool thing with for loops is that you specify at the beginning how many times they run for. So instead of having like a general expression like this, a for loop only runs for a set amount of time. See, this has a potential to run for an infinite amount of time if you just keep typing the wrong password over and over and over and over. But with a for loop, you have to specify it'll only run 10 times. It'll only run 5 times. It'll only run, however many times. So to create a for loop, basically we're going to say for I in range 100. Okay, so that's kind of a lot compared to how simple the while loop was. So let's go over this. First, let's start with this range function, okay? And this function, sort of idea of a function, should seem pretty okay with you guys. Remember, we have our print function, right? We have our int function, our str function, our float function, all those functions. So we have a function called range, right? And we're giving it this number of 100. And if I run this code, we see that we get, oops, let me clear this actually. We get all the digits from 0 to 99. So we get every number from 0 up until 100. Okay? So it's like this range function is giving us this sort of series that we traverse over, right? So we have our for I. So what's that saying? So it's saying for every number within this, what this range function has given us, right? We're going to go through each one and we're going to print it out. So I'll come up with a sort of better visualization for it. So let's say we have like a list, right? It's 0 to 99, just like how this range function has given us. And it looks like this, right? What our I is doing is for every I in this, it's going to go through each one. So it's going to go through the 0, and it's going to print that 0 out. After there's nothing else to do, it's going to move on to the next one, which is a 1, and it's going to do that. And it's going to go to the 2, and it's going to do that. So it's sort of iterating over this sort of set of numbers that this range function has generated for us. So that's what the for I is doing, okay? And this I actually can just be whatever you want it to be. It's a normal variable. So it's like I can make it j, I can make it x, you can make it number for num. The reason why it's I is that's typically just convention. You should do a for I. So that's your general for loop. So I'm able to specify that it's able to go all the way to 99. So let's say I want to make a for loop that goes up to 9, 0 to 9. I would type in for I in range 10, right? Because it's every number up until that 10. If I did want to include that 10, then I would just add 1 to that. I'd make it 11. So it's just like that. So this, again, is one of those things where we're going over it right now, and it may not make that much sense. But trust me, as we talk more about our concepts, it'll all sort of come together. Right now, on a syntactical level, that's all. This is just what you need to understand. It's just a for I in range, and then do whatever you want to with the I variable that's created. So, okay. What about if we don't want to, just do 0 to 11 or 0 to 10? What if we want to do 4 to 11 or 4 to 10 or all the odd numbers or all the even numbers? This range function, it allows us to give more inputs. So here, right now, I'm going to print out all the numbers from 4 to 10. So I've put a 4, comma, and then my 11. If I run that, I get 4 to 10. So what does this sort of mean? Well, think of this first number as your starting point, right? Our I variable is starting at 4, and then it's going to go all the way up to, but not including our 11, which means we get 10. So if I wanted say I wanted the numbers from 20 to 100, right? 20 to 101. Why am I putting 101? Because again, it goes up to, but doesn't include that. So if I do 20 to 101, see right here, actually let me clear this so we don't get the output from the previous run. We get that 20, and then we go all the way to 100. Cool. What if I only want to print, what if I want to skip over some numbers, right? What if I want to do 20 and then 22 and then 24 and then 26 and then 28, right? I want to jump. Then we can add in something else called a step. So usually when you count, you step by one, right? You say 1, 2, 3, 4. The difference between all of those is 1. So let's say I want to do 20, 22, 24, 26. I'm jumping by 2. So then my step would be 2. I'm stepping up by a value of 2. So if I clear this, run that, see I get 20, then I get 22, 24, all the way up to at 100. So this is probably a little bit confusing now. So what are we looking at with this? Let me just go over the range function one more time. Range. You have a starting value, you have an ending value, and then you have a step. And you'll notice that even when I didn't specify the step, it still worked. When I didn't specify that starting value, it still worked. So the only thing you have to have, is that that end value. But if you don't, if you want to specify things like start, end, and step, then you can do that as well. So now I'm going to print all the numbers from 40 to 100 with a step of 5. So what that should look like is 40, then 45, then 50, then 55, 60, 65. And you see how this is only able to run for a set amount of time. We don't have to specify a condition or anything like that. So does the for loop sort of make sense? And again, it's more of it's sort of a syntax thing that I want you guys to get an understanding of, not necessarily like why it's doing what it's doing, because that's something that'll just come with time. So if you guys are okay with that, which I'm not seeing any questions, let's build a little project with our for loops. And it's going to be super simple. We're just going to print out all of the odd numbers, and then we're going to print out all of the even numbers. Okay? So we're going to print them out from 0 to 100. So we're going to say print all the even numbers from 0 to 100. Okay. Let's start with our base syntax of a for loop, right? We have our for, and then we have whatever variable we want to call it. I'm just going to call it number, right? For number in, and then we have our range function. Okay. So we're going to start at 0. We want to go to 100. Okay. So we know that we have to add 1 to that 100. It has to be 101. Why? Because our range function will take us up to 101, but not including. Okay. And now we need to figure out what step do we want to take. Even numbers, right? So we have 0, 2, 4, 6, 8, 10. I'm seeing a pattern there, and the pattern is that I start at 0, and then I add 2 to each one. So that means my step in that case would be 2. So let's print that out. Let's print the number then. Hopefully we should get all of our even numbers from 0 to 100. If we do that, bingo. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, so on and so forth. So that's us printing out all of our even numbers. Cool. How about we try it with the odd numbers, right? Print all of the odd numbers from 0 to 100. Okay. Let's just clear this and let's restart. Okay, what is our for loop syntax? Well, we'll say for, and again, I'll just use number in range. Well, we last time we started with the 0, right? and it got printed out. But we know that even numbers start with 1, because we have 1, 3, 5, 7, 9. So that means that in this case, since we're printing out the the odd numbers, sorry, we're going to start at that 1, but we're still going to go to 101. We're still going to go up to 100. And we're going to step by 2. So with this, it was really just a matter of changing our starting point. So then if I print this number out, I get all of my odd numbers from 1 to 100. And of course, that 100 doesn't go in because it's not an odd number. It's an even number, even though it's included within our range. So it's like you're specifying the numbers you can get. So 1, 3, 5, 7, 9, all of that. That's how you print your even and your odd numbers. So it's 2 little mini projects we've done with the for loop. Let's do one more. How about we add up all of the numbers from 0 to 100. We're going to take 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. So this is a situation where our for loop, it's great, right? But let's create that structure again. For, I'll use I this time because I is what you normally use. So for I in range. Well, usually we would specify our step and our everything, but we're going from 0 to 100 and we're using a step of 1. So there's really no need for us to have to specify the start and the step. All we have to do is specify that end value, right? And since we're ending at 100, we have to make this 101. We have our colon, tab in, print. Let's see if we get all the numbers from 0 to 100. And bingo, all the numbers from 0 to 100. Okay, so we have all the numbers from 0 to 100. Now we need to have a way to sort of add them up into a large variable, into a large sum. So let's actually create another variable called sum. And sum starts off as 0. It has no value. Okay. So then for every I value I have, I'm just going to add that to the sum, right? So I'm going to say sum plus or equals that I value. And again, this plus equals is just like saying our sum is just equal to the sum plus the I, whatever I is, whatever this value is. Okay? And I'll leave this print there. At the end, we should say the sum of all the numbers from 0 to 100 is placeholder. Put our F to format the string. Open up those curly brackets, and we put in the variable name, which is sum. Awesome. Let's try this out. Let's clear our console, actually. Now let's try it out. And look at that. The sum of all the numbers, I don't know if you guys can see that because it's all the way at the bottom and my picture might be covering it. But there you go. Yeah, the sum of all the numbers from 0 to 100 is 5,050. Okay, cool. What if we want to sum all the numbers from 0 to 200? Well, we just change this from 101 to 201. We clear this, run that again. See, the sum of all the numbers from 0 to, well, it should be 200, is 20,100. So that's pretty cool, right? So that's sort of how you can use those for loops to sort of do computations and things like that. And you'll notice that things that you should take away from this is that with a while loop, it runs with a condition, right, while something is true. So that means it gives way for it to be an infinite loop. With a for loop, it only runs for a specified period of time, right? So that's how those sort of things can work. And that's actually bringing us to the end of this lesson. So I don't think I'll have any time to touch on functions. I don't think we'll have any time to go over these practice problems. But does everyone sort of understand all the things we touched upon today? We touched upon our for loops, we touched upon our while loops, and we did a bunch of stuff with our Boolean data types and all that jazz from last class. So actually, are you guys okay with all the content we covered in last class? So last class, commenting, mathematical operators, comparison operators. If you guys are okay with that, then that's fine, because we did spend a lot of time reviewing it and we built projects with this. This loop stuff, it's all pretty new. Yeah, Maria asked, can we do more of them next time? Of course. Yeah, I'm definitely going to plan on having some practice problems with these loops. I hope the practice problems that we did with the the logic and the if statements, I hope that helped, because we did spend the majority of the class working on that, and we'll spend the majority of next class working on these loops, and we'll make a couple games and whatnot. But I hope you guys are proud of yourselves, because you guys did do a lot of coding. We went kind of crazy today. I hope you guys had fun with the whole rock, paper, scissors thing. We have 10 minutes left. So yeah, none of these questions really apply to what we went over today. Does anyone have any questions over the content, where we're going to go next with the course? Anything like that? Any concerns that they want to go over? Because I'd be happy to address those. And of course, I do encourage you guys to try to get your own practice. You can use sites like Practice Python to get some project ideas, get some inspiration. And the cool thing about Practice Python is you can it gives you like answers as well. You can see people's answers and how they did stuff. So it's just a good way to get exposure and whatnot. So I'm not seeing any questions. I don't have anything to tell you guys. I haven't decided when the next date for the lesson will be. So I really encourage you guys to head over to my profile page on Teach, and join my Discord, join my Instagram. I will post reminders and things like that. Of course, within a 72-hour period, so you guys have time to prepare. And this lesson, of course, will go. The recording, at least for this lesson, will go up on teach.tv soon after I stop the stream. So yeah, thanks for being awesome, guys. Make sure to keep practicing. Take care of yourselves. Again, any questions, reach out to me. And yeah, just have yourself a good day. Take care of yourselves. And follow the social medias, because I still haven't figured out my next stream date. And I'm trying to get a more concrete stream schedule. I'm hoping that in the month of July, when I have things more figured out, we'll do Saturdays and Sundays. We'll do Saturdays for an hour and a half, and then we'll do Sundays for only 30 minutes, just to do a quick review. And if you guys are okay with that idea, then I'd love to hear your feedback. So yeah, thank you for a good lesson. Take care of yourselves, and I will see you guys next time.